Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome back. Today we're going to be looking at how to solve systems of equations with matrices. Matrices are great because we can computerize them. So in this problem, I could come in and I could, if I have a graphing calculator, and I could tell it to make a matrix. And I'm going to, basically it's organizing everything into a spreadsheet. So my A has a -6, my B has a 2, my C has a -3, my constant is 23. My A has a 5, my B has a 4, my C has a 3, my constant's -12. A is 1, B is 2, 3 is C, and my constant is 6. So we can just see it's a way to drop off the variables but still keep the numerical part organized. When you write it on paper, you'll see a dotted line right here separating the coefficients from the constants. And this is going to be what's called an augmented matrix. If you're computerizing it with an augmented matrix, we can do something called Gaussian elimination. Also known as reduced row echelon form, or RREF. So I'm going to go back in my matrix menu. I'm going to look for math. I arrow up so I can find it faster. There's that RREF, matrix A. And you'll notice that it took all my coefficients, and now this says 1A, no B, no C, is -5. No A, no C, just 1B is 1. And with the bottom row, we see 1C is 3. So through some magic calculator math, we went from this complicated matrix down to a reduced row matrix. And that is actually going to be the point of this video, is to learn how to do most of it. I am either going to have you do lower triangulation or upper triangulation. I'm not going to have you do both. You could continue. I just find it's extra steps when I think it's easier to go back to our basic algebra and back substitute. So we are going to mostly do lower triangulation in this particular video, but again, upper triangulation works. But we are going to learn what did the calculator do, because I know some universities have you actually write down the row operations, so you actually have to understand what's going on. If you're a high school student or if you do not have a graphing calculator, Desmos does have a Desmos matrix webpage that's different than the regular Desmos, where you can actually type in your matrices and do the reduced row echelon form there. So our first step in doing this is obviously going to be making the matrix. So -6, 5, 1, that was our A's. 2, 4, 2, that was our B's. -3, 3, 3, that was our C's. Then we'll get this. 23, -12, 6. So there's some options that you have here. You can add rows, multiply by a non-zero scalar, or you could switch rows if you really wanted to. Or you can do some combination of both. Okay, now think about this. This is row 1, row 2, and row 3. I am going to strictly focus on lower triangulation in this video and be very specific, because if you're not very careful about the order in which you do this, it's like driving around and round and round in a parking lot at Christmas time trying to find a parking spot. Every time you make another loop, someone takes that parking spot you saw. So I'm going to do these in a very, very specific order. Our goal in step 1 is to get a 0 in that location. So our goals are to gain zeros in certain locations. I can either add rows, I can multiply rows, I can switch rows, or I can do some combination of both. So if I were to take row 3 and multiply it by -5, that would be a -5 right there, and then add row 2, I would get a 0. And since I want to store it or keep it or save it right here, I'm going to store it in row 3. So I need to take -5 times the numbers 1, 2, 3, and 6, and add 5, 4, 3, and -12. You can type it into a graphing calculator just like this. We're just going to do the math here. We'd have -5, -10, -15, -30, 5, 4, 3, -12. When I add those, 0, -6, -12, -42. Step 2 is we want to get a 0 directly above our first 0. So that would be right here. Now the thing is I cannot multiply by 0, so I can't use the bottom row. So that means I'm going to have to make these additive inverses to where they add to 0. So I would need to take row 1 times 5 and row 2 times 6, and I want to put that answer in row 2. Okay, this time I'm going to do it with a fancy calculator since I showed you with the math by hand. So this time I'm going to show you with the calculator. 5, -6, comma 2, comma -3, comma 23, plus 6, right? 5, 4, 3, -12. You'll notice this is kind of like writing code. You know, do this times this, store it here. We're going to get 0, 34, 3, and 43. So that top line is still -6, 2, -3, 23. The second line, oops, the bottom line, is 0, 34, 3, and 43. And my new line is 0. Scratch that. Okay, so now that we've done that, we typed it in the calculator. The top line stays the same because we haven't changed what's stored there. The bottom row and when we did this math in our calculator, it said 0, 34, 3, and 43. So to complete the lower triangulation, here's a diagonal, right? Because here's our dotted line. Here's what's called your main diagonal. Lower triangulation means there's a triangle below that diagonal, which means I need to get a 0 here. Once I do that, and I have a perfect triangle of zeros, I can easily answer my question. However, if I use the top row and I have a number plus 0, it's going to lose one of these two zeros. So in this last step, you have to use row 2 and row 3 because they both have a 0. That way 0 plus 0 stays 0. Okay, so I'm going to just take row 2 times 6 and row 3 times 34, and I'm going to put it in row 3. I don't care that the numbers are going to be big because I'm going to use the calculator because, again, I'm making my life easy. Could I go ahead and do it by hand? Absolutely. And I will show an example here in a little bit where I write everything out by hand. That way you can see how I would write it if I was not using the calculator. Okay, so 6, we had 0, 34, 3, 43, plus 34 times 0, negative 6, negative 12, negative 42. You get 0, 0, negative 390, negative 1170. And I know you might be thinking, oh my goodness, those are very, very large numbers. And I get that. But remember, this was our A column, this was our B column, this was our C column, and this was our constants. So let's read that bottom line back to us now. That bottom line says no A, no B, negative 390C equals negative 1170. Oh, well, I'm just going to divide. C equals 3. Now our next line up. No A, 34B, plus 3C, and instead of writing C, I'm going to go ahead and substitute what C is. C was 3, right? I'll write that in pink so you remember where that came from. Equals 43. So 34B plus 9 equals 43. 34B equals 34. Oh, B equals 1. And now that top line, negative 6A plus 2B minus 3C equals 23. Negative 6A, 2 minus 9 is negative 7. I'll add that 7 over. A equals negative 5. Oh, I forgot to move that up. Sorry about that. Let me go back up to where the calculator did that magic math, and we can see that negative 5, 1, and 3 were indeed the X, or the A, the B, and the C. So why do this? Well, somebody had to write the program for the calculator in the first place, and like I said, some of the college classes are going to ask you to write these row operations out. They might ask you, how do you gain a 0 here? So it's really important that sometimes we know what's going on. Not all teachers are going to make you utilize matrices, and not all teachers are going to make you use matrices by hand. If you ever have to solve for 4 or more variables, knowing how to use the computerized matrices is a blessing because it will save you a lot of time, and it also allows you to check your work, and it depends on the goal of your problem whether or not you have to show every step as you go. To x plus 3y minus z equals negative 1. 3x minus 8z equals negative 1. 5y plus z equals negative 1. So here we have an equation with some gaps in it, a system of equations, and we're going to pop these into a matrix. 2, 3, they skip the x. 3, they skip the y. Negative 1, negative 8, 1. Negative 1, negative 1, negative 1. And one thing I like about matrices is they can take up a lot less space than writing out all your variables. Okay, so if you notice, step 1 is done. We already have a 0 in this location. So step 2, since step 1 is done, is to get a 0 in this location right here. Okay, so I'm just going to go ahead. I know I'm changing row 2, so I'm going to keep the top row and the bottom row the same. And this time I'm going to show you how to do it so that I don't have to write out so much. But again, I need to know what I'm doing. So to make these add to 0, I would need to multiply the top row by 3 and the second row by -2, which is like subtracting 2 times, right? Then we'll add those together because technically we're doing adding rows. And we're going to put that answer in row 2. So again, this is just telling us our command. All right, so I'm just going to grab a pencil. Row 1 times 3. Well, that's 6, 9, -3, -3. Times -2, that's -6, 0, 16, and 2. Now I'm going to add my pencil marks. So -6 and 6, 9 plus 0, -3 and 16, -3 and 2. Okay. Now, our next step was to get that lower triangulation, and we want to gain that 0 right here. Again, I have to use my bottom 2 rows, otherwise I will lose a 0, and it's like driving around the parking lot looking for a spot at Christmas time. When the malls, well, when Walmart is packed or whatever. Sam's Club on a Sunday, that too. So make sure that we're using these 2 rows, and we're only changing the bottom row. So 2, 0, 3, 9, -1, 13, -1, -1. We could keep doing this process to gain more zeros in the top and get a full reduced row echelon form. I just choose to stop after a lower triangulation because that is sufficient. Okay, to get these to add to 0, they both have to be 45. One would have to be positive, one would have to be negative. So I'm going to take 5 times row 2 and -9 times row 3, add them together, and we're putting our answer in row 3. So pencil marks, timesing by 5, we get 0, 45, 50, 65, and -5. Times by -9, we get 0, -45, I'm going to back that up. That's adding, multiplying numbers. Okay, so times -9 times -9. Teach me to make videos in the evening, right? So we have 2, 3, -1, -1, 0, 9, 13, -1. Okay, 0 and 0 makes 0. 45 and -45 is also 0. 65 minus 9 is, let me just double check because I'm saying it's 56 in my head, but just gotta, yes, it is 56. You ever have those days where you just, your brain is fried? -5 and 9 makes 4. Okay. We have a lower triangulation. This is great. So we're going to take our last one, which was 56z equals 4. And if you type that into a calculator, you will find out z equals 1/14 again, like I've said in other videos, use fractions. If you try to write down all the decimals on the calculator, you're still rounding, and you don't want to have to worry about significant figures and rounding error. Okay, moving up. 9y plus 13 times 1/14, because that's z, equals -1. So that gives us 9y plus 13/14 equals -1. So subtract that 13/14 over. We get -27/14. Divide by 9, we get -3/14. Now that we have our z and our y, we're going to back substitute and get our x. So I'm just going to take the top row now, which was 2x plus 3 times that y minus 1 times that z. Notice how I wrote the coefficient -1. Makes things easier sometimes. That gives us -1. We have 2x plus -9/14 plus -1/14 equals -1. Combine like terms. -9 and -1 add to -10/14, but -10/14 is -5/7. Now, I am not a fan of double signs, so I'm going to change this to 2x minus 5/7. When I add that to the other side, I get 2x equals 2/7. Divide by 2, I get 1/7. So now I have that ordered triple of x, y, and z. So the trick to matrices is just to make sure you get your lower triangulation done efficiently. You'll have a number, a number, a number, a number, a number, a number. I made this too tall. A number, a number, a number. Step 1, step 2, step 3. Step 1 and step 2 can be flip-flopped, but step 3 has to come after them. So make sure you're focusing on gaining zeros, and that should guide you through your matrices. Now, I know we've talked about no solution, all solution. If you have a number, 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 I'm making up that 0, I don't really care. 0, 0, 0, 5. Or we'll just put number. This bottom line says 0 equals a number. Well, unless that number is 0, it's not true. So this would be no solution. If we have number, 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 actually, usually a 0 here. Number, number, 0, number, 0, 0, 0, 0. Well, now that bottom row says 0 equals 0, and that's when all our variables have canceled, and that's at infinitely many solutions. So if you watched my last video, when we solved these by hand, same equation solved by hand, right? So in the last video, we had one that was, go ahead, 3 by 4 matrix. 2x minus 3y plus 5z equals 1. 3x plus 2y minus z equaled 4. And 4x plus 7y minus 7z equals 7. And we're getting really, really messed up looking answers. But if you remember, everything was based on the fractions of 13ths. That was, I'll go ahead and write that problem down here. doing it on a calculator, we can see the bottom row says 0 equals 0, so it's many statements. And it went 1, 0, 0, 0, 1, 0, 7 thirteenths, negative 17 thirteenths, 0, 14 thirteenths, and 5 thirteenths. So if you're having to write these in a college algebra class, the top row says x plus 7 thirteenths z equals 14 thirteenths. Well, we can get x by itself really easy by saying 14 thirteenths minus 7 thirteenths z. The same thing happens with our y variable. We have y minus 17 over 13z equals 5 over 13. So we just add it to the other side. 5 over 13 plus 17 over 13z. And now we can write our ordered triple. And that makes life a lot. Let me change up my matrix to the other problem we did in the previous video where we were solving systems of 3 equations. If you want to, you can pause the video and write that back down. I'm going to come back. Whoops, not what I wanted to do. Okay, so if you want, pause the video, write the equation down, but when I go ahead and do this, I get, make that a fraction. We can see the bottom row now says 0, 0, 0, 1. So 0 equals 1, so this is a false statement. So there I can see it's no solution. So matrices can really help us add things up before we even start doing the problem. Again, if you are trying to work out something with multiple variables, maybe you're in a statistics class, matrices are definitely going to be your friend when you have to solve for a lot of variables. If you have questions, please drop them in the comments. Again, I can go further into the full RREF, reduced row echelon form mathematics, but again, I prefer lower triangulation. You can do upper triangulation.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.